The dark is leaning over Voyager right now, whispering through charged gas. A machine built in 1977 is listening with its last few working senses. Each faint pulse reaches Earth almost a day later, and NASA says the old probe is hearing something no human has ever heard before. If you love true space stories that get stranger the deeper they go, subscribe now. Stay with me because this is not the kind of mystery that gets smaller with time. Voyager 1 started as a planet mission, not a forever mission. NASA launched it on September 5, 1977, during an age of film cameras, small memory chips, and slow radio links. The plan was very simple by space standards. Fly past the giant planets, gather data, send pictures home, and do what no spacecraft had done before. It worked better than almost anyone expected. Voyager 1 raced past Jupiter in 1979 and Saturn in 1980. It showed storms, moons, rings, and details that had never been seen up close. Then, instead of dying after its biggest jobs were done, it kept flying into the outer dark. That long extra journey changed the meaning of the whole mission. Voyager stopped being only a visitor to planets. It became a scout sent toward the edge of the sun's reach. Later, it became the first human-made object to pass beyond that reach and enter interstellar space. To get why that matters, picture the sun as more than a bright ball in the sky. The sun is always throwing out charged particles. That flow is called the solar wind, and it pushes outward in every direction. Together with the sun's magnetic field, it makes a huge bubble around the planets called the heliosphere. Inside that bubble, the sun still controls most of the local space weather. Outside that bubble is the interstellar medium, which is the thin gas, dust, and charged material that drifts between stars. Scientists had wanted to touch that outside region for decades. Voyager was the first machine that had any real chance to do it. But no one knew exactly where the crossing point would be. There is no signpost floating in space. There is no bright line painted in the dark. There is only a rough border where the pressure from the sun meets the pressure from the wider galaxy. Scientists broke that frontier into parts so they could study it. First comes the termination shock, where the solar wind slows down fast. Then comes the heliosheath, the outer layer where the sun still matters but begins to lose its grip. And finally comes the heliopause, the boundary between the sun's bubble and true interstellar space. Voyager 1 passed the termination shock in December 2004, about 94 times farther from the sun than Earth is. That unit is called an astronomical unit, or AU. 1 AU is the Earth-Sun distance, about 93 million miles. So by 2004, Voyager was already in a place almost too huge for the human mind to picture. Even then, scientists still expected the final crossing to have clear signs. They thought particles from the sun would drop. They thought particles from outside the solar bubble would rise. And many expected the local magnetic field to swing into a new direction once Voyager crossed the border. Some of those things did happen. Solar particles fell sharply. Cosmic rays from outside the heliosphere rose. That looked like the outside was finally pushing in harder than the sun was pushing out. But one detail refused to behave. The magnetic field did not swing as cleanly as many scientists expected. It stayed pointed in a way that made the crossing harder to prove. That one stubborn clue turned a historic moment into an argument. Here is the twist that makes the story feel almost impossible. Voyager 1's main plasma instrument had stopped working back in 1980. That was the tool that should have directly measured the gas around the spacecraft. So when the biggest moment came, the team had to solve the mystery with other clues. NASA now says Voyager 1 entered interstellar space on August 25, 2012, but the team did not announce that right away. They had to wait, argue, compare data, and build confidence. They were trying to define a place no one had ever measured before. Then a delayed gift arrived from the sun itself. In March 2012, months before the official crossing date, the sun blasted out a powerful eruption. That shockwave kept moving outward through space. More than a year later, it reached Voyager and shook the plasma around the spacecraft. That matters because Voyager still had one instrument able to hear those vibrations. Its plasma wave system could detect how the charged gas around it was ringing. The pitch of the ringing told scientists how tightly packed the electrons were. Higher pitch meant higher electron density. When the signal arrived, the answer was shocking. The plasma around Voyager was far denser than the team expected inside the sun's outer bubble. In fact, the density matched what scientists expected in interstellar space. That was the clue that tipped the case. When researchers studied the pattern more closely, they found weaker events in data from late 2012. Those older signals fit the same rising trend. By tracing that trend backward, they could point to late August 2012 as the moment Voyager first met interstellar plasma. That is how the crossing date was locked in. Did you think the first trip out of the solar system would be a clean step over a line? Or did you always imagine the border would be strange, rough, and full of doubt? Tell me below, and if this story is already pulling you in, like the video and subscribe for more. NASA even turned the plasma wave data into audio that people could hear. Space itself was not carrying normal sound the way air does on Earth. What Voyager detected were plasma vibrations. Then engineers converted those signals into sound for us. The result was a rising tone that felt eerie, lonely, and deeply unsettling. That eerie tone helped create the headline people still talk about. Voyager detected something unbelievable. But what is unbelievable is not just that the probe heard a strange signal. It is that nearly empty interstellar space turned out to have structure, motion, pressure, and a kind of hidden voice. Most people imagine deep space as perfect silence. No air, no wind, no weather, no motion worth talking about. Yet Voyager showed that the thin gas between stars can still vibrate when a shock passes through it. Even the emptiest places are not as empty as they look. And then the mystery grew. Scientists first thought these plasma wave signals might appear only when strong solar shocks slammed through the region. That would mean short events, separated by long, quiet gaps. But later work showed something more surprising. A team led from Cornell studied Voyager 1 data and found a weak, steady plasma emission in interstellar space. People called it a hum. Not a loud roar, not a dramatic burst, but a thin, almost constant tone. The darkness out there was not silent between shocks, after all. This changed the picture again. Scientists expected rare, sharp readings. What they found was something closer to a background presence, a soft signal that stayed on long enough to become a new way of measuring the density around the spacecraft. That may sound like a small detail, but it is huge. Before this, scientists had only short snapshots of the plasma around Voyager. Now they had a more steady method to track changes over time. That meant the old spacecraft was not only crossing a new region, it was beginning to map it. The density itself was another surprise. Based on the signal, electron density around Voyager began rising in 2013 and reached much higher levels by about the middle of 2015. Reports describe the change as roughly a 40-fold increase from earlier levels. So the region beyond the heliopause was not a flat nothing. It was changing as Voyager moved through it. Imagine being told that the first object beyond the sun's bubble is not floating through still darkness. It is drifting through a place with waves, changing density, and a constant whisper. That is why the discovery hit so hard. Voyager was turning the myth of empty space into a real physical environment. Then came another puzzle. If Voyager was truly outside the heliosphere, why did the magnetic field still seem oddly familiar? Why did it not twist into a very different direction as clearly as many had predicted? That question bothered scientists for years. One strong idea said Voyager had crossed the boundary but was still in a region where the sun's influence bent the local magnetic field. In simple words, the spacecraft was outside the bubble, but not far enough away to see fully untouched interstellar conditions. The border was not a knife edge. It was more like a borderland. That idea matters because it changes the story from simple to strange. Scientists expected a sharp handoff from the sun to the galaxy. Voyager showed that the sun leaves fingerprints beyond the place many people would call the end. Its pressure and past eruptions still shape the nearby region. So now the discovery sounds less like one single surprise and more like a chain of them. Scientists expected a boundary. Voyager found a layered transition zone. Scientists expected silence. Voyager found a hum. Scientists expected the outside to become simple once the crossing was done. Voyager found new levels of mess and motion. Scientists expected old instruments to fade into history. Voyager kept opening new questions after 40 years in flight. That is the kind of result no one can fully plan for. Did you ever picture space between the stars as a dead, blank void? Or does the thought of a steady hum out there make the universe feel more alive and more unsettling at the same time? Write your answer in the comments, and if you want more stories like this, tap like and subscribe. Now shift from what happened then to what is happening right now. Voyager 1 is still moving outward through interstellar space. NASA says it will reach one light day from Earth in November 2026. That means light itself, the fastest thing in nature, needs about 24 hours to cross the gap. Just stop on that for a second. When engineers send a command, they do not get a quick reply. They wait almost a full day for the command to arrive, then almost another full day for a signal to come back. One simple exchange can take nearly 2 days. That delay turns every repair into a long game of patience, and Voyager has needed repairs. In late 2023, the spacecraft started sending back bad engineering data. It was still receiving commands and still responding, but the health information coming home made no sense. This was dangerous in a very basic way. If you cannot read the health of the spacecraft, you cannot know what to fix safely. The mission team had to dig through old designs and old software logic from a machine built in the 1970s. They were trying to repair a flying relic from more than 15 billion miles away. The trouble was traced to memory used by the flight data system. That is the part of the spacecraft that packages engineering and science data before transmission. The team found that part of the code had stopped working correctly. And because Voyager is so old, there is no easy reset button. Their solution sounded like surgery done through a keyhole. Engineers divided the affected code into sections and moved those sections into different places in memory. Then they updated all the references so the pieces would still work together. If one step failed, the spacecraft might not recover. In April 2024, the first big sign of success arrived. Voyager 1 resumed sending usable engineering data. After months of waiting, the team could once again read the spacecraft's basic health. Later, more science data returned as well. That fix alone would make Voyager remarkable. But the mission has another problem that will never go away. It is running out of electrical power. Voyager uses a nuclear power system that slowly loses output every year. NASA says each spacecraft loses about 4 watts of power each year. That may not sound like much in daily life, but when every heater, every science tool, and every onboard system is fighting for scraps, 4 watts can decide what survives. Power loss is no longer a future problem. It is the mission. For years, engineers made a plan for what would be shut off and when. Each decision asks a painful question. What science is most important now? Which instrument gives the best chance to keep learning as the craft weakens? In February 2025, NASA turned off Voyager 1's cosmic ray subsystem to save power. That instrument had helped measure energetic particles for decades. Then, on April 17, 2026, the Low-Energy Charged Particles instrument, called LECP, was shut down too. That tool had worked almost non-stop since launch. LECP had measured ions, electrons, and cosmic rays from both our solar system and the wider galaxy. It helped scientists study pressure fronts and changing particle regions beyond the heliosphere. Losing it was not a small cut. It was like turning off one more sense on a spacecraft already surviving on very little. And yet the choice also shows what NASA values most right now. Voyager 1 still has 2 science instruments operating. One listens to plasma waves. The other measures magnetic fields. Look at what remains alive. The ears and the compass are still on. The very tools tied most closely to the interstellar mystery are the ones NASA is trying hardest to keep alive. That says everything about where the biggest questions now live. Mission managers have said shutting off LECP bought roughly a year of extra power margin. They are also working on a broader power-saving effort with the nickname the Big Bang. The goal is to shift to lower power systems where possible and keep the spacecraft warm enough to survive. If it works, Voyager may keep speaking longer. So when people hear a loud headline about NASA confirming something unbelievable, the deeper truth is better. Voyager is detecting unbelievable things while it is also fading, piece by piece, in the dark. It is hearing plasma waves in interstellar space. It is measuring a magnetic field still shaped by the sun's old reach. It is showing that the region just outside our solar bubble is not quiet, pure and simple. It is layered, active, and still connected to what the sun once did. That is the real shock. The first step between the stars is not clean. It is alive with leftover influence. And that teaches us something about home. The heliosphere is not only a science idea on a chart. It helps shield our part of space from some harmful radiation coming from the galaxy. If we understand how its edge behaves, we understand more about the environment wrapped around Earth. That also matters for the future. One day humans will send newer probes much farther than Voyager. Maybe not tomorrow, maybe not in our lifetime, but one day we will aim beyond this first rough border on purpose. When that happens, Voyager's data will be part of the map. Think about how amazing that is. A craft designed when many of today's grandparents were young is still drawing a guide for missions not yet born. That is not just good engineering, that is human curiosity refusing to expire. Would you keep every last instrument on for as long as possible, even if the mission grows riskier? Or would you shut things down early to make sure Voyager survives a little longer in any form? Tell me what you would choose, then like, subscribe, and keep going with me. There is also a more personal side to this story. Voyager carries the golden record, a message from Earth made for any far future finder. It has music, sounds, greetings, and pieces of human life pressed into a form that might outlast our oldest cities. That record is still riding through the dark right now. But the record is almost a second story compared with what the spacecraft is doing in the present. Voyager is not just carrying our message, it is still sending messages back. Each one crosses a distance so huge that even light needs almost a day to travel it. We often talk about space as if distance itself is the most mind-bending part. But distance is only half the wonder here. The other half is endurance. Voyager has survived cold, radiation, old hardware failures, shrinking power, and growing silence, yet it still contributes to science. That endurance makes the hum feel even stranger. If a shiny modern probe heard a plasma tone in interstellar space, it would be big news. But an old machine, launched before most home computers existed, is the one hearing it. That turns the discovery from impressive into almost unreal. And remember, the hum is not some side note. It offers a way to measure the density of interstellar plasma over time. It helps scientists ask how nearby interstellar space is structured. It may also help reveal when Voyager finally gets far enough away to sense a less distorted region. That last part is very important. Right now, researchers believe Voyager may still be feeling effects tied to the heliosphere. The sun's bubble may be behind it, yet the local magnetic field may still carry the marks of that nearby giant structure. The spacecraft is outside, but perhaps not fully free of the edge. So the mission is still unfinished in the deepest sense. Voyager has crossed the line, but it has not yet answered all the questions that crossing created. Where does the sun's last influence truly fade? How smooth or rough is the nearby interstellar medium? What creates the weak, steady plasma emission? Is it caused by small-scale motion in the gas? Is it a background effect of larger waves moving through the region? Or is it something scientists still have not guessed correctly? That is the beauty of this story. The farther Voyager goes, the more it shows us that our first ideas were too simple. The map keeps gaining detail right where we expected empty blank space. The darkness is full of behavior. And there is one more reason people connect so strongly with Voyager. It is old, distant, and alone, but it still matters. In a strange way, it feels almost human. Not because it thinks, but because it endures. It keeps going long after the job description ended. It keeps speaking after many expected silence. It keeps finding meaning in a place that looks empty. That is why people who do not even follow space news still care about this mission. Voyager also reminds us that real discovery is often quieter than fiction. No alien fleet appears. No glowing gate opens in the stars. Instead, a faint change in plasma density becomes one of the biggest clues in modern space science. That is how truth often works. It arrives as a signal so small that most people would miss it. Then someone listens carefully. Then the signal changes the map. Then the map changes how we see our place in the universe. In this case, the signal said that interstellar space near us is denser than many expected just beyond the heliopause. It said that the region has waves and changing conditions. It suggested that our sun's influence reaches farther, or at least leaves more trace, than the clean model promised. And it said the border around our cosmic home is alive. There is another layer to the mystery that makes the story even more powerful. Voyager is not measuring this strange region with fresh hardware built last year. It is doing it with systems designed in the 1970s, protected by engineers who must think several moves ahead. Every bit of data that arrives now feels earned. The spacecraft itself is not large. It is about the size of a small car, with a dish antenna that catches and sends radio signals across impossible distance. Long booms stretch outward to place sensitive tools away from the craft's own electronics. Those parts were built to survive a hard mission, but not to keep working for nearly 50 years. That is why each surviving instrument now has a kind of story of its own. The plasma wave system is like Voyager's hearing. It listens for tiny changes in charged gas. The magnetometer is like a way to feel the shape and pull of invisible fields around the spacecraft. Together, those two tools are telling the late chapter of the whole mission. They are not showing moons or rings anymore. They are showing the texture of the space between stars. They are helping answer a question older than the space age itself. What is it really like out there? For decades, many people spoke about interstellar space in very broad terms. It was the deep outside, the giant beyond, the black ocean past the planets. Those words were not wrong, but they were blurry. Voyager is replacing blur with detail. That detail comes in a surprising form. Not huge images, not color views of alien landscapes. Instead, it comes as shifts in pitch, changes in density, and patterns in magnetic behavior. Tiny clues are building a very big picture. Scientists also care about this because our solar system is moving through the galaxy. That means the heliosphere is not sitting in a perfectly still place. It is traveling through local interstellar material, and that material can change. If the outside pressure changes, the shape of the sun's bubble can change too. So Voyager is not only telling us about one lonely craft, it is helping us understand the larger shield around the planets. That matters for radiation, for space weather, and for how energy and particles move through our neighborhood. The edge of the solar system is not just far away, it is part of the system that protects home. Some researchers compare the heliosphere to the wake of a ship moving through water. You can imagine the sun plowing through the galaxy while throwing out solar wind in all directions. The farther from the sun you go, the more that outward push has to fight the pressure outside. Voyager is sampling that fight from the far edge. And the fight is not quiet. Old solar eruptions can keep moving outward for months and even years. When they finally reach Voyager, they can shake the plasma around it and make the local environment ring. That is one reason the probe can still hear major events from our star long after leaving the planets behind. This makes deep space feel less cut off than many people assume. Voyager is outside the heliosphere, but the story of the sun is still catching up to it. The past travels outward. What happened near the sun long ago can still matter far beyond Pluto and the other planets. That long connection between past and present gives the mission a strange emotional pull. A flare from the sun can leave Earth, race outward, and years later tap Voyager on the shoulder. Then Voyager sends the evidence home over nearly another full day of light travel. It is like a chain of messages stretching across time itself. And here is something else worth remembering. Voyager 2 also reached interstellar space, but in a different direction and at a different time, in 2018. That gave scientists another precious comparison point. The two spacecraft do not fly side by side. They sample two different paths through the frontier. That comparison matters because no single crossing can tell the whole story. If one spacecraft sees a certain boundary shape, that might be local. If the other sees something different, then the heliosphere may be uneven or shaped by local outside conditions. With only two probes, the picture is still thin, but it is much better than one line alone. Voyager 2 helped confirm that the border is not the same everywhere. Its crossing happened at a different distance than Voyager 1's crossing. That tells scientists the sun's bubble is shaped by pressure, motion, and magnetic forces that do not act evenly in all directions. Our cosmic shield is not a perfect ball. That point may sound technical, but it changes how we imagine our place in space. Home is not wrapped in a smooth bubble like a child's toy. It is wrapped in something more like a living shape, pushed and squeezed by the galaxy outside. Voyager is helping us feel the outline of that shape from within. Did you expect the border around our solar system to look neat and round? Or does it make more sense that the galaxy presses on it in messy ways? Tell me what picture lives in your mind, then like the video and subscribe if you want the next layer of the mystery. There is also a reason NASA keeps sharing updates even when the news sounds small. A single instrument turning off may not look dramatic from the outside, but every change matters when you are nursing one of the oldest working spacecraft ever built. Each update tells us what the mission can still do and what may be lost next. When NASA shut off LECP in 2026, it was not because the science had stopped being valuable. It was because the spacecraft was running out of power, and the team had to choose survival over keeping every tool awake. Those choices are painful because there will never be another Voyager exactly like this one. Once a tool goes silent, that chapter ends. Yet the mission keeps finding ways to surprise people. Even the phrase, "one light day," carries emotional weight. By late 2026, Voyager 1 will be so far away that the signal path from Earth to the spacecraft matches the distance light travels in 24 hours. That is not just a number, it is a feeling. It means the craft is living in a time zone of delay. Earth acts, then waits. Voyager answers, then Earth waits again. The whole relationship is stretched thin across space, but it still holds. That should matter to all of us, even if we never study physics. Earth is not floating in some abstract cartoon of space. It sits inside a real neighborhood shaped by the sun and pressed on by the galaxy. Voyager is helping us learn what the edge of that neighborhood feels like. It is a little like sending the first boat beyond the known shore. At first, people only want to know whether land has ended. Then the boat reports currents, pressure, weather, and strange sounds from the new sea. Suddenly, the world beyond the map becomes a place, not a blank. That is what Voyager has done. It has turned the edge of the solar system from an idea into an environment. And every time it sends home one more whisper, the outside becomes a little more real. That is why NASA's confirmation feels so powerful. Not because one moment solved everything, but because each new measurement keeps proving that there is more out there than our first neat drawings showed. More structure, more motion, more uncertainty, more wonder. Voyager did not just cross a boundary, it revealed that the boundary itself is a mystery. Do you think Voyager will one day reach a region where the sun's fingerprints finally disappear? Or do you think the border between our star and the galaxy is always going to be messy and hard to define? Leave your view below, and if you want to follow the next clue, subscribe and turn on notifications. Someday the mission will end. Maybe it will be because the power falls too low. Maybe a heater will go cold, a system will fail, and the spacecraft will finally stop answering. There will be no crowd around it, no final speech, no sudden flash. There will only be silence where a signal used to be. But even then, Voyager will still be moving. It will keep drifting through the dark for ages beyond any human plan, and it will still carry the record of who sent it. For now, though, the old probe is still alive. It is still listening. It is still measuring. And it is still telling us that the first step into interstellar space is far stranger than anyone once believed. Maybe that is why Voyager keeps holding the public imagination. It is not only far away, it is proving that age does not erase value. A machine can outlive its first purpose and still become most important at the end. That feels rare in any part of life. When Voyager left Earth, no one could promise it would still be teaching us in 2026. Now it is teaching us that the edge of the solar system is active, that interstellar space has texture, and that careful science can turn a faint signal into a new map. That lesson reaches beyond astronomy. It says the unknown is not empty. It waits for something quiet enough to listen. So, if this story gave you chills, stay close for what comes next. Subscribe, turn on notifications, and tell me in the comments what you think Voyager will discover before its final signal. Then share this with someone who loves space, because they need to hear this mystery too. Thank you for being here. Thank you for staying curious, and thank you for watching.